Welcome to MG Chemicals Tech Talk Episode 8, Improving Surface Quality of Epoxy Resin. In this video, we will be using our 832WC, which is a two-part optically clear epoxy resin. The mix ratio for this product is 2 parts resin to 1 part hardener by volume. We stir the components together for 2 minutes to ensure complete mixing, which in turn produces a lot of air that ingresses into the mixture that appears as small bubbles dispersed throughout the resin. We will now prepare 5 samples from the mixed resin to demonstrate the efficacy of removing the bubbles using 5 different techniques. We are adding a die as a reference to represent the different techniques employed. We will now pour the mixed liquid into these housing units made of polycarbonate. The first sample is our control, so we're going to set this one aside, having done nothing to try and remove the bubbles. For the second sample, we're simulating using a flame to heat up the top layer of the mixture. The idea is that the flame heats the resin and the ingressed air becomes less soluble, rising to the surface. Once at the surface, the bubbles expand, reducing surface tension until the bubble breaks. Next, we have a heat gun, which is the same concept, just using a different tool. The advantage over using a flame is that you are less likely to char with a heat gun, but you must be careful not to accidentally blow dust into the mixture. This next sample will employ a vacuum degassing technique. For this, we need a vacuum chamber and a pump which pulls the air out. The low pressure causes the air to rise to the surface and froth. After some time, the bubbles break and receive back to the mixture, where the surface eventually becomes smooth. For our final sample, we're simply putting the mixed material into the oven. Similar to how the flame and heat gun were used, the hot oven makes the bubbles less soluble, bringing them to the surface where they break. Certain packaging options afford us the luxury of a bubble-free finish without having to do any treatments after dispensing. This dual cartridge, for example, can be fitted with a mixing tip that mixes the 2 components as they pass through the helices down the nozzle. Also, specialized mixing equipment can be used that removes air as it mixes, providing a turnkey solution. Now for the results. We see our first sample, the control, with no intervention, still has lots of bubbles embedded within it. Sample 2, which used the flame, worked very well to remove the air, giving the cured sample a nice, smooth appearance. The same can be said for sample 3, which used a heat gun to achieve the same results. Sample 4 used a vacuum chamber, which sucked all the ingressed air from the sample to leave a bubble-free finish, while sample 5, which used a hot oven to cure the sample, has also given us a clean, clear finish.